again, good morning everyone. I am Jerwel Duque and I will discuss you one of the most interesting topics in pharmaceutical calculations, and that is the dose calculation. So in calculating doses, there are several factors to consider, and there are also several formula that we may use in order to solve or in order to calculate such doses. And today, I would like to show you my problem. My problem is to calculate the dose for a patient who is 5 years of age, 40 inches in height, and weighing 34 pounds for a drug with an adult dose of 100 milligrams using the Young's rule, the Cowling's rule, the Clark's rule, and using the BSA equation. In order for us to easily solve the problem, let me identify the given, what are required to find, and the formula that we will use in order to solve the problem. Okay, so what are given? First, the child's age, which is 5 years of age, height, which is 40 inches, weight, which is 34 pounds. Age, height, and weight are called the body statistics. And last but not the least is the drug adult dose, which is 0.1 kilogram or 100 milligrams. Now, what are required to find? First is the dose for the child, using the Young's rule, the Cowling's rule, the Clark's rule, and the BSA equation. I will show you the formula in order to solve the problem. Okay, first is conversion. Yes, we should convert the necessary body statistics to be used in the problem. And second is the dose calculation using the Young's rule. In Young's rule, we have this formula, age divided by age plus 12 times adult dose. In the Cowling's rule, we have this age at next birthday in years times adult dose divided by 24. In Clark's rule, we have this weight in pounds times adult dose divided by 150. The 150 there is the average weight of adult in pounds. The BSA equation, okay, the first one is the patient's dose. In order to get the patient's dose, we must divide the patient's body surface area by 1.73 m squared times drug dose in milligrams. However, the problem is how to get the body surface area. So the formula in getting the patient's body surface area is the patient's height in centimeters times drug dose in milligrams divided by 3,600. Okay, so let's start solving the problem. First is, of course, the conversion. So we will convert the height. Remember, the child's height is 40 inches. Then we'll convert this to centimeters. Okay? So, 40 inches. In 1 inch, we have 2.54 centimeters. So, 40 times 2.54 centimeters is, I will use my calculator, times 2.54, we have 101.6 centimeters. So let's convert the child's weight. Okay, so remember, his weight is 40 pounds, and we will convert that to kilograms. So, 40 pounds times, there are 2.2 pounds in 1 kilogram. So this is 40 divided by 2.2 pounds. So, okay, so we got 18.18 kilograms. Okay. So there, the patient's height is 40 inches or 101.6 centimeters. The patient's weight is 40 pounds or 18.18 kilograms. Okay, so step 2 is the dose calculation using the Young's rule. So this is the first, Young's rule. So the formula once again is age divided by age plus 12 times adult dose. So the child's age is 5 years old divided by, again, 5 plus 12 times our adult dose, remember, is 100 milligrams or 0.1 kilogram. But what is needed is the milligram. 100 milligrams. So let's solve. 5 plus 12 is 17 times 100. So, basing from the Young's rule, 5 divided by 17. The patient's dose is 29.41 milligrams. It's 29.41 milligrams. Okay, so next is the dose calculation using the Calding's rule. So again, with the Calding's rule, we are following the formula age at next birthday, so that's the age plus 1, times adult dose divided by 24. So let's substitute. So remember the patient's age is 5 plus 1, that's 6, times the adult dose 100 milligrams divided by 24. So solve. 6 times 100, that's 600 divided by 24. So we got 25 milligrams. So that is the patient's dose in Calding's rule. Okay, so third we have the Clark's rule. So those calculations using the Clark's rule. So the formula is weight in pounds times adult dose divided by 150. So again, our patient's weight in pounds, we have 40 pounds. 40 pounds times adult dose, which is 100 milligrams divided by 150. So what is this 150? Remember, 150, this is the average weight of an adult. So let's solve. 40 times 100 milligrams divided by 150. We have 26.67. 26.67 milligrams. So this is the patient's dose in Clark's rule. Okay, so let's proceed to the last but not the least, the dose calculation using the BSA or the body surface equation. So in order to get the BSA, the patient's BSA, the formula is the patient's height, or that's squared patient's height in centimeters, times squared drug dose in milligrams, divided by squared 3,600. So substituting, we have 101.6 centimeters times 100 milligrams drug dose and squared 3,600. So let us solve. Squared 101.6 centimeters times squared 100 milligrams, that is 100.79 divided by squared 3,600. So we got 1.68 m squared as the patient's BSA. Okay, so this is the patient's BSA, 1.68. Okay, and last but not the least, we will solve the patient's dose based on the body surface area. But first, that we'll need to do is to get the patient's body surface area using the formula patient's height in centimeters times patient's weight in kilograms divided by 3,600. So let's substitute. So the patient's height in centimeters, we have 101.6 centimeters. It is squared times patient's weight in kilograms, which is 18.18 kilograms, divided by squared 3,600. So let's solve. Squared 101.6 times squared 18.18 divided by squared 3,600. So we got 0.72 m squared as the patient's BSA. Okay, so the next that we will do is to get the patient's dose using the BSA. Okay, so let's get the patient's dose based on the body surface area. So let's substitute the formula. Patient's body surface area, which is 0.72 m squared divided by 1.73 m squared times the drug dose, which is 100 milligrams. So 0.72 divided by 1.73, sorry, 0.72 divided by 1.73 times 100 milligrams. So we got 41.62 milligrams. So this is the patient's dose, 41.62 milligrams, in using the body surface area.
My name is Jairo Arcarillo, and I am going to demonstrate to you how to solve a problem under drug dose calculations using dimensional analysis. My problem here is a 16-week regimen for a brand of nicotine patch calls for a patient to wear a 21 milligram patch each day for the first 6 weeks, followed by a 14 milligram patch each day for the next 2 weeks, and then a 7 milligram patch for the next 2 weeks to complete the treatment regimen. In all, how many milligrams of nicotine are administered? First step is we need to state the given. So a patient needs to wear a 21 milligram patch each day for the first 6 weeks, and a 14 milligram patch each day for the next 2 weeks. And to complete the regimen, the patient needs to wear a 7 milligram patch each day for the last 2 weeks. So we are going to use a dimensional analysis. For the first one is, there are 21 milligrams in one patch. And the patient needs to wear a patch each day and there are 7 days in 1 week. And the patient needs to wear it for 6 weeks. So we have to cancel what needs to be cancelled. So 21 milligrams times 7 times 6 is 882 milligrams. So these are the number of milligrams that the patient needs to milligrams of patch that the patient needs to wear in 6 weeks. So we are going to repeat the same method for the next 2 givens. So in one patch, there are 14 milligrams, and the patient needs to wear 1 patch a day, and there are 7 days in 1 week, and the patient needs to wear a patch, a 14 milligram patch in 2 weeks. So cancel. 14 milligrams times 7 times 2 is equal to 196 milligrams. Lastly, there is 7 milligrams in 1 patch, and the patient needs to wear 1 patch a day, and there are 7 days in a week, and the patient needs to wear it for 2 weeks. So cancel again. So 7 milligrams times 7 times 2 is equal to 98. problem here was, in all, how many milligrams of nicotine are administered. So, we need to simply add these results in order to get the total quantity of nicotine in milligrams administered to the patient. So, 882 milligrams plus 196 milligrams plus 98 is equal to 1,176 milligrams of nicotine.
I'm Paul Patrick Pataksil. I will solve a problem under the topic enlarging formulas, specifically under solving by factor method. The following is a formula for 100 triple estrogen capsules. Calculate the quantities of the first 3 ingredients in grams and the last 2 ingredients in kilograms, required to prepare 5,000 such capsules. Given are the following: estriol with 200 milligrams, estrone with 25 milligrams, estradiol with 25 milligrams, polyethylene glycol 1450 with 20 grams, polyethylene glycol 3350 with 20 grams. We are solving for the quantity of the first 3 ingredients in grams and the last 2 ingredients in kilograms. In order to get the factor, we will use this formula. Substituting the formula, quantity to be prepared is 5,000 capsules. Standard formula is 100. 5,000 divided by 100 is 50. Therefore, 50 is the factor. To determine the quantity of each ingredient, we will multiply it to 50. Milligrams times 50 is 10,000 milligrams. 25 milligrams times 50, 1,250 milligrams. 25 times 50, 1,250 milligrams. 20 grams times 50, 1,000 grams. 20 grams times 50, 1,000 grams. Note that the first 3 ingredients should be in grams. Therefore, we should divide it by 1,000. 10,000 divided by 1,000, 10 grams. 1,250 milligrams divided by 1,000, 1.25 grams. 1,251. And the last 2 ingredients should be in kilograms. We will also divide it by 1,000. 1,000 grams divided by 1,000, 1 kilogram. 1,000 grams divided by 1,000. Therefore, 10 grams of estriol, 1.25 grams of estrone, 1.25 grams of estradiol, 1 kilogram of polyethylene glycol 1450, and 1 kilogram of polyethylene glycol 3350 in order to produce 5,000 capsules.
Formulas. The problem will be calculate the quantity of ingredient A, B, C, and D to prepare 35 grams of the following formula of an ointment. The given will be ingredient A, 50 grams, ingredient B, 73 grams, ingredient C, 27 grams, ingredient D, 11 grams, ingredient E to make 5,000 500 grams. We are solving for the quantity of ingredients A, B, C, and D in order to prepare 35 grams of the formulation. We're going to use this formula, desired quantity over standard formula, in order to get the factor. For the solution, we're going to follow this step. First, we're going to get the factor using this formula. Now we're going to substitute. We're going to cancel the unit. Since it's 0.07 using the factor. Second step is we're going to multiply the factor to each ingredient's quantity. Filgrastim prefilled syringe contains 480 microgram for active constituent in each 0.8 ml. The equivalent concentration is A 0.6%, B 0.384 mg per ml, C 0.06%, and letter D 0.06 gram per ml. For 180 microgram and 0.8 milliliters. The required to find is percentage strength. So first, we need to convert 480 microgram to milligram. So 480 microgram times 1 mg over 1000 microgram. So cancel. So the answer is 0.48 kilogram. 0.48 milligram, we divide it into 0.8 ml. So the answer is 0.6. So the equivalent concentration is 0.6%.